Hello, this presentation is on derivatives. What does derivative mean? Derivative actually is the instantaneous rate of change or the rate of change at an instant. So, rate of change at an instant. Or if we or also we can refer to it as the slope at an instant, instantaneous slope. So what's the formal definition of derivative? So the derivative of the function f with respect to the variable x, or the rate of change at an instant of a function f with respect to the variable x, is what? It is the function f prime. That prime means derivative, or the instantaneous rate of change, whose value at x is the following. Now, we learned to use the definition of derivative or the slope formula to find the instantaneous rate of change, which is the limit as h approaches 0 of f of x plus h minus f of x over h. This formula is the slope formula, slope at an instant. Now, we have to assume that this works as long as the limit exists. The limit must exist for the instantaneous rate of change to exist. So the if f prime of x exists, we say that f has f has a derivative at x, or f is differentiable at x. F has a derivative at x, or f is differentiable at x. Another thing we need to keep in mind is a function that is differentiable. It means a function that has derivative at every point of its domain. It means at any instant in its domain. Then it is a differentiable function. Now, to find the derivative or the instantaneous rate of change, we can use derivative rules. Instead of using each time that formula, it is very complicated for complex functions. Now, the first tool we're going to learn is called the power rule. So the power rule. Power rule says if n, some number n, is a real number, then the derivative of x to the power of n, so n can be any real number, is n, the power n, times x to the power of n minus 1. So it means you use that power as a coefficient, and then you subtract 1 from the power, and this will be the derivative. Now, we will go over the proof for this formula. However, there are 3 proofs, and the one we're going to be looking at is applicable only when the power is positive integer number. So we're going to say let f of x equals x to the n, where n is a positive integer is actually a natural number. Okay, so where n is a natural number. So the other two proofs actually are good when n is any n is real, n does not have the restriction of being just integer, positive integer. So the other two proofs actually cover every other number. So how do we do this? We're going to start with the limit definition. It says, let's since we're looking for the derivative, so f prime of x, it means the derivative of the function f, is the limit of f of x plus h minus f of x over h as h approaches 0. Now, what is f of x? So f of x is x to the power of n. So that means when I substitute, this is going to be the limit of x plus h to the power of n, which is f of x plus h to the power of n, minus f of x. What is f of x? Is simply x to the power of n. That's f of x. All divided by h as h approaches 0. Now, what is x plus h to the power of n? Well, we need to use binomial theorem to find that. So I'm just going to put the expansion of x plus h to the power of n, but if you really need to understand how that expansion works, then you have to refer back to binomial theorem. So after using binomial theorem to expand this, or to FOIL x plus h to the power of n, then it's going to be the following. So limit as h approaches 0 of x to the power of n plus nx to the n minus 1 times h plus n times n minus 1 over 2 factorial times x to the n minus 2 h squared plus many terms in between nx to the times h to the n minus 1 plus h to the n. Let's not forget minus x to the power of n. This one, let's not forget that. This is all divided by h. So now we notice that x to the n minus x to the n, that's a 0. So what's left is limit as h approaches 0 of pretty much what's left is all this. Everything in green. So nx to the n minus 1 times h plus n times n minus 1 over 2 factorial times x to the n minus 2 h squared plus many other terms, and then nx to the h to the power of n minus 1, all divided by h. Now, notice that h is the coefficient of the first term, it is the coefficient of the second term, it is the coefficient of the last term, it is the coefficient of every term in between. And this whole expression is divided by h. That means we can divide by h every single term. So this will be limit as h approaches 0. The first term divided by h would be, so n times x to the n minus 1 times h divided by h, that's nx to the n minus 1. Plus, divide the second term by h, it will be n times n minus 1 over 2 factorial times x to the n minus 2 times h, because h squared divided by h is simply h, plus many terms in between, n x h to the power of n minus 1 divided by h, that's actually h to the n minus 2. And then the h on the bottom divided by h is 1. So the denominator becomes simply 1. Now, when you find this limit, what you do, you plug in a 0 for h. So when you plug in a 0 for h, this goes to 0 because h is 0. So h is 0. So that term goes to 0. Every single term in between will go to 0. All these terms go to 0. And the last one as well go to 0 because h is 0. The only thing that is left is n x to the power of n minus 1. That means any x raised to some power, this formula would actually would be correct to use to find the derivative. So, as I said, the other proofs for n when it's not a positive integer, the proof would end up with the same results. So all cases you will end up with n times x to the power of x to the power of n minus 1. Now let's look quickly at some derivative notations, and then we do some examples. So if you see this notation, which is f prime of x, that means the derivative or the instantaneous rate of change. If the function is labeled with the letter y, then y prime means also derivative. This also means derivative of y, the function y with respect to x, or derivative of function f with respect to x, or derivative of the function f of x with respect to x. The most common ones are f prime of x, y prime, dy dx. You'll see this one too. But make sure you get familiar with the derivative notation. Let's work on this example. Example 1 says, find each of the following. So derivative of x to the power of 5 with respect to x. So applying the formula we just learned, the formula says if you have x to the power of n, and we want a derivative of x to the power of n, then it would be n times x to the n minus 1. In example A, n is 5. So it will be 5 to the power of x, 5 times x to the power of 5 minus 1, which is 5x to the power of 4, and that's the instantaneous rate of change. Example 2, find y prime, which means find the derivative when y equals x. X is the same as x to the power of 1. So it means y prime equals 1 times x to the power of 1 minus 1. 1 times x is the same as x. or let's keep it 1. Let's do one more step. 1 times x to the 0. X to the 0 is 1, so it will be 1 times 1, so the answer is 1. So derivative of x is simply 1. Let's look at example C. The derivative of f of x equals 4. So write f prime of x equals the derivative of 4. Now, there are two different ways how we can do this. First idea is this. 4 can be written as 4 times x to the 0. Right? So if that's the case, so let me change something here, then it would be derivative of 4 times x to the 0. Derivative. Or let's let's do the first option. So the first option would be if we sketch the graph of f of x equals 4, then the graph would be simply a horizontal line parallel to the x-axis. The slope of a horizontal line is 0, so we know that. This is y equals 4 or f of x equals 4. We know that the slope equals 0. So it doesn't matter at which point on the line, the slope will always be 0. So it means at an instant, which is at any point on the line, the slope will be 0. So the derivative of a constant will be 0. Graphically, we can see it. Now, the other method, actually, there's a property that we need to learn before I can use it, but I'm going to use a different value. So first we say f prime of x equals the derivative of 4, which was 0, so we got that one. Now, how about if our function is, let me use different functions. So g of x equals 1. That's a better example. 1 can be written as x to the power of 0. Now, applying the formula, g prime of x, which is derivative of x to the power of 0. Now, the formula says move that exponent, which is 0, in this case, times x to the 0 minus 1. That's the formula. Now, it doesn't matter what this is. It's multiplied by 0, so the answer is going to be 0. The reason why I realize that trying to show you how it works using the formula when f of x is 4 is because we need to know that 4 times x derivative is the same as 4 times derivative of x. Okay, let's work on example D. Example D says find the derivative of f of x equals x to the negative 3. So f prime of x equals the derivative of x to the negative 3. We use the formula, so we're going to move the negative 3, this is the power, times x to the negative 4. Goes minus 3 minus 1, which is negative 4, and that's the derivative. Let's look at example E. The instantaneous rate of change, which means derivative. We just want to make sure that we understand different ways how to ask question. Okay, let's do this one. So s prime of t means the derivative of the function s at t, which is what we have. We have x to the power of 1/3. So now you move the 1/3, which is the power, times x to the 1/3 minus 1. 1/3 x to the power of negative 2/3. And would like to move the x to the denominator, so it's going to be 3 x to the 2/3, you don't have to worry about rationalizing. So either we keep it as 1 over x to the 2/3, or we can do the cube root of x squared. Either answer is fine. Example F, dy dx. So dy dx. I would like to first write this as x to the 1/2, because we don't have to take the derivative of square root of x without going through the power rule. So we know that the square root of x is x to the power of 1/2. Now we just apply the power rule on this. So 1/2 x to the 1/2 minus 1. 1/2 x to the negative 1/2. And then we move it down. We move the x to the negative 1/2 to the denominator. So x to the, 2 times x to the 1/2, which is 1 over 2 square root of x. So this is acceptable. This one also is acceptable. So constant multiple. So we're not going to prove this formula. We're just going to give you what the formula is. So if you take the derivative of some constant c times the function u, so what you can do, you can hold on to the constant and take the derivative of the function. So which is cu prime. That's the idea pretty much. So whenever there is a constant, you can hold on to the constant. It is going to be just a coefficient of the derivative of the function. So the constant times the derivative of the function. Here's an example. Find example 2a. Find each of the following. Derivative of 4x squared. So as I said, there is a 4 there. We're going to hold on to it. Derivative of x squared is 2x. You can apply the formula. It's going to be 2x. And then you simplify, which is going to be 8x. Derivative of derivative of e times x. E is a constant. We should not forget that. So it's e times derivative of x. And e still is a constant. Derivative of x is 1, which is e. Example C, derivative of negative 1/3 times x to the negative third. So when we take the derivative, looks like this is missing something. So the question should be, let's do something like that. That's the question. It's missing the derivative. So let's hold on to the 1/3 and then take the derivative of x to the negative 3. So negative 1/3. Derivative of x to the negative 3 is negative 3 x to the negative 4. Now we just need to simplify. Negative 1/3 times negative 3, that's a 1. So 1 times x to the negative 4, which is 1 over x to the 4. Example D, negative x to the pi. Same thing. The question is missing the derivative. Means find the parentheses under the prime, or find the derivative of negative x to the pi. So what we have to do is hold on to the negative 1. The negative is the same as negative 1. And then apply the power rule. So it would be pi is constant, pi times x to the power of pi minus 1. You just apply the formula, which is negative pi times x to the pi minus 1. No need to move this to the bottom because pi is greater than 1, so it will remain on top. the sum and difference rule. The sum and difference rule says that if you have the sum of two functions, u plus v or u minus v, then the derivative would be the sum of derivatives, meaning, or the difference of derivative, meaning it will be u prime plus or minus v prime. So it means you take the derivative of u plus or minus the derivative of v. Okay, so example 3a, the derivative of 4 plus 5x cubed. Well, it's the same as saying, okay, I want the derivative of 4 plus I want the derivative of 5x cubed. Derivative of 4 is 0 because it's constant, and derivative of 5x cubed, 15, because 3 times 5, 15, x to the power of 3 minus 1, which is 2, which is 15x squared. Example B, you have 4 terms in here. So it will be derivative of negative 6x cubed. Of course, once you become comfortable with derivatives, you can skip this step. Plus x squared over 2 derivative minus 1 over x. 1 over x, actually, I like to write it as x to the negative 1. This one. So let me make a note. This is the same, similar to x to the negative 1. Okay. Plus 10 derivative. So derivative of negative 6x cubed is negative 18x squared. Derivative of x squared over 2 is x. Derivative of x to the negative 1, well, it will be minus times another minus, because it's going to be negative x to the negative 2, plus derivative of 10, which is 0. So negative 18x squared plus x plus 1 over x squared. Because you got a negative times a negative, that's positive. And then move x to the negative 2 down, so it becomes 1 over x squared. Now let's look at the product tool. Product tool says if we have a derivative of the product of two functions. So it's not simply the derivative, the product of derivatives. No, it's not the derivative of u times derivative of v. That's not the case. Of course, there is a proof for this one. We're not going to go over it. So the formula says it would be derivative of u, the first function, times v as is, unchanged, plus derivative of v, which is the second function, times u, which is the first function, as is. So u prime v plus v prime u. That's the formula. Example 4a, find the derivative. So applying the formula, it is going to be the derivative of the first function, which is the derivative of 2x plus 1, times 3x minus 5, unchanged, plus derivative of 3x minus 5, second function, times the first function as is. Okay, good. What's the derivative of 2x plus 1? That's 2. Times 3x minus 5. What's the derivative of 3x minus 5? That's 3. Times 2x plus 1. Now we can simplify. 6x minus 10 plus 6x plus 3, which is 6x plus 6x, 12x, minus 7. Example B. So y prime equals the derivative of 2x times square root of x. Now, we can hold on to the 2 as a common factor. So we're going to apply the product tool formula on x and square root of x. Let's write square root of x as x to the 1/2. Okay, so we hold on to the 2, and then we take the derivative of x times square root of x, but square root of x is the same as x to the 1/2. So 2, hold on to it. We're going to write down the product tool, the derivative of x times x to the 1/2 plus derivative of x to the 1/2 times x. That's the end of the product tool. Derivative of x is 1 times x to the 1/2. Derivative of x to the 1/2 is 1/2 x to the negative 1/2, because you do 1/2 minus 1, times x. Now, what's left is just simplifying. So 2 times, now x to the 1/2, which is same as square root of x, plus, we have x times x to the negative 1/2. If you add the exponents, this x is to the power of 1. I don't want you to confuse the 1 with the derivative, so I just added the 1 there. So that this exponent is 1, and that's negative 1/2. So you add the exponents, which will be 1/2, because 1 minus 1/2 is 1/2. So far we have 2 bracket square root of x plus 1/2 x to the 1/2. We still can simplify, because this is going to be 2 times square root of x plus square root of x over 2. 1/2 times square root of x is same thing as square root of x over 2. Actually, we can keep it like this. We don't have to go any further. Or let's simplify it. Sorry, simplify. So this is going to be 2 times square root of x plus square root of x over 2. And then the 2 crosses out with the 2. And 2 times square root of x plus square root of x is 3 times square root of x. Okay, so let's move on to example C. Example C, we need again to find a derivative, which is derivative of ex cubed, ex times the cube root of x, which is the same as x to the 1/3. Let's save time, write it down at the first step. So e is constant, we can hold on to it. So it means we're really taking the derivative of x times x to the 1. I mean, we do the work on the product of x and x to the 1/3. Okay? E is constant. So we can probably skip steps a little bit. Derivative of x is 1 times x to the 1/3 plus derivative of x to the 1/3 is 1/3 x to the power of 1 minus 1/3, which is negative 2/3, times x. So I just applied the product tool. So e times cube root of x plus x times x to the x times x to the power of negative 2/3. So 1 minus 2/3, that should be 1/3. So it's a cube root of x over 3. Okay, so we can combine this. It's e times, this is going to be 4 cube root of x over 3, which is, we can keep it like this, or we can write it as 4 over 3 e times cube root of x. Okay, example D. Example D. Find the derivative of x squared minus 1 times negative 1 over x. So we're going to do y prime equals derivative of x squared minus 1. I'm going to write the formula first. So x squared minus 1 derivative times negative 1 over x plus derivative of negative 1 over x times x squared minus 1. Now, the 1 over x, we have to do something about that, is the same as x to the negative 1. X to the negative 1. 1 over x is the same as x to the negative 1. So derivative of x squared minus 1 is 2x times x to the negative 1 minus, what's the derivative of x to the negative 1? First of all, you have that negative, which I already wrote over here. And then you have the power rule. When you apply the power rule, it will be negative x to the minus 2, because subtract 1 from negative 1, which is negative 2. That's the derivative. Times x squared minus 1. So it's 2x, or what's 2x times x to the negative 1? That's 2, because x times x to the negative 1, you add the powers, will be 1 minus 1, which is 0. X to the 0 is 1. Now, you got a minus times minus, which is plus, I'm talking about this minus and this minus. So minus times minus is plus. Then what do we have? We have x to the negative 2 times x squared minus 1. X to the negative 2 times x to the 2, x to the negative 2 times x to the 2, that's x to the 0, which is 1. And then x to the negative 2 times negative 1, that's minus x to the negative 2. So we got 1 minus x to the negative 2. So 2 plus 1 is 3, and then minus x to the negative 2, which is minus 1 over x squared. We can leave this as is, or you can find the common denominator. Doesn't matter. This is in regards to the product rule. Let's do one more thing, which is the quotient rule. Quotient rule is the last rule we're going to learn in this section. So the quotient rule says if you are taking derivative of the quotient of the ratio of two functions, then the formula says, well, you take the derivative of the function on the numerator, okay, which is u prime, times function v as is, unchanged, minus the derivative of the function v times the function u as is, unchanged, all divided by the bottom function squared. That's the formula. There is a proof for the formula as well. Okay, let's apply out the formula on the first example. I'm going to show all the work. So we do f prime of x, which is the derivative of x minus 4 over 2x. The formula says take the derivative of the function on the numerator times the function on the denominator minus derivative of the function on the denominator, or in the denominator, times the function in the numerator as is, unchanged. All this divided by the function in the denominator squared. Okay, so what's the derivative of x minus 4? That should be a 1, because the derivative of x is 1 and the derivative of 4 is 0. So 1 times 2x. minus, what's the derivative of 2x? Well, that should be 2 because the derivative of x is 1 times the constant 2. Times, of course, let's not forget x minus 4, our function. This is all divided by 2x squared, which is 4x squared. 2 squared is 4, and x squared is x squared. All is left is to simplify. So we got 2x minus 2x when you distribute. That's a 0. And then you have minus 2. You have minus 2 times negative 4. So that would be 8 over 4x squared. Let me make sure I didn't make any mistake in here. So 2x minus 2x, which is 0. Negative 2 times negative 4 is plus 8. That's the only thing left. So, and then let's simplify. 8 over 4 is 2 over x squared. Let's do example B. Same thing. We're going to apply the quotient rule. So y prime, which is derivative of this function. So derivative of x squared plus 4x derivative times x minus 1 minus derivative of x minus 1 times x squared plus 4x, all divided by x minus 1 squared. So derivative of squared, derivative of x squared is 2x. Derivative of 4x, that's 4. Times x minus 1. Minus derivative of x is 1. Derivative of 1 is 0. So it means minus 1. Times x squared plus 4x. All divided by x minus 1 squared. Now all is left is FOILing, distributing, and then simplifying. 2x times x, that's 2x squared, plus 4x minus 2x, that's plus 2x, minus 4, minus x squared, minus 4x. All divided by x minus 1 squared. 2x squared minus x squared, that's x squared. 2x minus 4x, that's negative 2x minus 4. All divided by x minus 1 squared. Now, if you notice, if we factor the numerator, if we try to factor, it could be a prime. So 1 multiplies to negative 4, 1 multiplies to negative 4 and adds to negative 2. Yeah, that is nothing. So if we can't factor, then there's no way we can simplify this. So this is the final answer. Of course, some of you may ask, should we distribute the numerator? Well, you can. You don't have to. You can if you want. You don't have to. If the question is a multiple choice question, let's say you're working on a multiple choice question, then depending on the choices that you have. Okay, let's work on the next example. Same thing when I take the derivative. So it would be derivative of, do something here. I would like to write the function square root of x as x to the 1/2. Okay, so it's going to be the derivative of x to the 1/2 minus 1 times x plus 2 minus derivative of x plus 2 times x to the 1/2 minus 1. Of course, here we don't have to write it this way. We can keep it as square root of x, but I just want to be consistent. That's the only reason. all divided by x plus 2 squared. Let's not forget that. So let's verify before we move on. So derivative of x to the 1 half minus 1 times x plus 2 minus derivative of x plus 2 times x to the 1 half minus 1. Okay, good. Now the derivative of x to the 1 half is 1 half x to the negative 1 half, because you move the exponent and then you subtract the 1 from the exponent. 1 half minus 1 is negative 1. Derivative of negative 1 is 0, so we can ignore that. So far, that's what we have, multiplied by x plus 2. Minus derivative of x plus 2, well, derivative of x is 1, and the 2, derivative of 2 is 0. Derivative of x is 1, derivative of 2 is 0, so we got only minus 1 in here. Times x to the 1 half minus 1. All divided by x plus 2 squared. Now we need to FOIL. We need to FOIL and distribute, simplify, and simplify. So we got 1 half x to the negative 1 half times x, which is 1 half x to the 1 half. Because this is x to the 1, that's x to the negative 1 half. So when you multiply them, you add the exponents. 1 minus 1 half is 1 half. Okay. Plus, it looks like we got a 1 half times 2, which is 1, times x to the negative 1 half. Okay. So we're done with that part. And then minus 1 times x to the 1 half, which is x to the 1 half. And minus 1 times negative 1, which is plus 1. All divided by x plus 2 squared. Now, let's simplify. 1 half x to the 1 half minus x to the 1 half. Looks like those are like terms, which will be negative 1 half x to the 1 half. Or let me use square root of x at this time. So square root of, or let me just do that when we're done. So 1 half minus 1 is negative 1 half. So, and then we have the x to the negative 1 half that is still there. Plus 1 over x plus 2 squared. Okay, let's simplify. So let's do something to quickly get rid of this kind of mess on the numerator. What we can do actually to resolve this without doing a lot of work is if we multiply the numerator by x to the 1 half, you have to do that for the denominator as well. So x to the 1 half times x to the 1 half, that's x to the power of 1, because 1 half plus 1 half is 1. So far I have negative 1 half times 1, which is negative 1 half. Then you get x to the negative 1 half times x to the 1 half, which is 1 half minus 1 half, 0. So x to the 0, which is 1. And then 1 times x to the 1 half, that's still x to the 1 half. Then on the bottom, you have x to the 1 half times x plus 2 squared. So last step, 1 minus 1 half, 1 minus 1 half is 1 half. And then we need the common denominator. So it would be, 1 half plus, let's put square root of x over square root of x times x plus 2 squared. Really, in this example, the derivative is not the challenge, it is the algebra. So what we end up with is this 1 plus 2 square root of x, common denominator, over 2 times square root of x times x plus 2 squared. So I'll let you work on this, figure out how I get from that step to the last one. This is all algebra. Don't get too intimidated or scared by this, because sometimes if the question is multiple choice, you may be able to keep it not completely simplified. Example 6 says find the horizontal tangents of the curve. So what does the question mean? Let me explain what the question means. So let's say you got, this is curve x to the power 4. Let's say we just take a piece of the curve just to explain what's going on. What the question means is find the horizontal tangent. So horizontal tangent, it means the tangent to the curve is a horizontal line. The tangent to the curve is a horizontal line. So let's say at this point, you notice that the tangent is horizontal. Let's say if we have another point over here, so the tangent will be horizontal. So what we need is we need the equations of the horizontal lines that are tangent to this curve. That's what the question is asking us to do. So the idea is horizontal tangents has a slope equals 0. So slope equals 0. That's the idea. This is what you need to keep in mind. But what kind of slope? Instantaneous slope. It means derivative. So slope equals 0, or more appropriate, y prime equals 0, because you want the instantaneous slope, or the instantaneous rate of change, or the rate of change at an instant is 0. So by this, we can just simply say, all right, we need to find y prime first. What is y prime? Y prime is the derivative of x to the power 4 minus 2x squared plus 2. Derivative of x to the power 4 is 4x cubed. Derivative of negative 2x squared is negative 4x. Derivative of 2 is 0. Then we have the derivative. Now we're going to say, okay, we want the derivative to be 0. We want the slope to be 0, so it means you want y prime to be 0. That means you want 4x cubed minus 4x to be 0. Now you can solve this by factoring the 4x. So you got x squared minus 1. Now you got the product equals 0. That means 4x equals 0, or x squared minus 1 equals 0. This is 4x equals 0 is true when x equals 0. X squared minus 1 equals 0. That's true when x equals plus or minus 1. So we have actually multiple tangent lines here that are horizontal. X equals 0. At x equals 0, we have a 0 derivative. At x equals 1, we have a 0 derivative. And at x equals negative 1, we have a 0 derivative. So what we have to do, you have to substitute the x value for x in this equation. That's what we have to do. So let's write them down over here. At x equals 0, y is 2. At x equals 1, y is 1 to the 4th is 1 minus 2 times 1 squared. So 1 minus 2 plus 2 is 0, so it's 1. Yeah. And then at x equals negative 1, that will be the same thing, y equals 1. So we have two horizontal tangents. y equals 2, y equals 1. It looks like I did a random graph, and this could be a 1 and 2 by chance. Find an equation for the line tangent to the curve at the given point. Find an equation for the line tangent to the curve at the given point. So we did an example like this before in the previous my previous presentation, but now we're just going to use the derivative formula. We're not going to use the definition of derivative, which is the limit as h approaches 0 of f(x) plus h minus f of x over h. So if we need to write the equation of the tangent line, then we need two things. We need the slope and we need the point on the line. The slope is a derivative. So let's take the slope, y prime. Let's find y prime and then we'll plug in a 1 for x. So y prime equals the derivative of x squared plus 3 over 2x, which is derivative of x squared plus 3 over 2x. We need to use the quotient rule. So it's going to be derivative of x squared plus 3, which is 2x, times 2x, minus derivative of 2x, which is 2, times x squared plus 3, all divided by 2x squared. Because we want the slope at x equals 1, then we don't have really to deal with much simplifying. So all we have to do is this. So y prime at x equals 1, this is a notation that we use when we want to find a derivative at some point, one of the notations. So all I'm going to do is substitute 1 for x in this expression. So it's 2 times 1 times 2 times 1 minus 2 times 1 squared plus 3. All divided by 2 times 1 squared. So we're going to have 4 minus 8 over 4. Let me make sure that I made no mistake. So we got 2 times 2 is 4. 2 squared is 1 plus 1, 3. No, 4. 4 times 2 is less, so minus 8. Okay, we're good. So 4 minus 8 is negative 4 over 4 is negative 1. So this is the slope, the instantaneous slope. Okay, so let's put m for the tangent line. All right. Now we need the point. We know the x-coordinate of the point, which is 1. How do we find the y-coordinate? You use this function to find the y-coordinate. So you substitute 1 for x. So you're going to say, okay, y equals 1 squared plus 3 over 2 times 1. That's a 2. So the point on the line would be 1 comma 2. Now we have our point, we have our slope, so we can write the equation of tangent line. So tangent line equation will be y minus 2 equals the slope, which is negative 1, times x minus 1. We can keep it as is, or we can simplify it. So y equals negative x plus 1 plus 2 plus 3. And that's the equation of the tangent line. Example 8. Question says, suppose u and v are functions of x that are differentiable at x equals 2 and that u of 2 equals 3, u prime of 2 is negative 4, v of 2 is 1, v prime of 2. So it's this bunch of information. We're going to use it to answer question B, A, B, and C. The question says, find the values of the following derivatives at x equals 2. Okay, now let's start with example A. Before we look at the data given above, what is the derivative of the product uv? It's u prime times v plus v primes times u. Right? Now, we want the derivative at x equals 2. In other words, we want this. We want u prime at 2 times v at 2 plus v prime at 2 times u at 2. This is not times 2, this is at 2 or of. So u prime of 2 or at 2 is -4. It's given. V of 2 is 1. That's also given. V prime of 2 is also given. It's 2. And v and u of 2, so u of 2 is 3. It's over here. So everything is given. -4 plus 6, so it's 2. That's the first one. Second one, we need to use the quotient rule. It's u prime. It's u prime. So it's u prime times v minus v prime times u over v squared. And all this u prime v prime u v squared and so on add 2. All of them add 2. So we can skip this and just go ahead and just answer. So u prime at 2 is -4. Let me change. So u prime at 2 is -4. V at 2 is 1. Minus v prime at 2. V prime at 2 is 2. Times u at 2, which is 3. All divided by v. V at 2 is 1 squared. Then let's simplify these numbers. -4 minus 6, -10 over 1, which is -10. Let's do this one. V prime times u minus u prime times v divided by u squared. Again, we need v prime at 2, u at 2, u prime at 2, v at 2, and u squared at 2. So v prime at 2, that would be 2. And u at 2 is 3. U prime at 2 is -4. V at 2 is 1. All divided by u at 2, u at 2, which is 3 squared. So 6 plus 4, 10. 10 over 9. The last one, 3 u prime minus 2 v prime plus 2 times, now we need to use the product tool on u times v, which is, we use the product tool, or actually what we can do to minimize a bit of work, we found in example A the derivative of uv. So derivative of uv is 2. We found it to be 2. Derivative of uv is 2. So we can use that already. We don't have to redo the work. So this one is 2 times 2. So that's going to be easier. So u prime at 2 is -4. So we got 3 times -4. And v prime at 2, v prime at 2 is 2. So minus 2 times 2. And this one is plus 2 times 2. So it's -12. Second and higher order derivatives. What this means, it means we can take multiple derivatives. It means we take the derivative of, let's say, a given function, and then we find a new expression, which is, we can call it another function. And then you can take derivative of the new function. and so on. So you can take multiple derivatives. So before we do example 9, let me give you a simple example just to understand the concept. Let's say we start with x to the power of 4. So if we take the derivative of x to the power of 4, that's going to be 4x to the power of 3. Now we can take the derivative of 4x to the power of 3, which is 12x squared. Then we can take the derivative of 12x squared, which is 24x. Then we can take the derivative of 24x, which is simply 24. If we take the derivative of 24, well, that's a 0, and it looks like it's dead end. This is what second and higher order derivatives mean. So let's go on and do example 9, which is the last example on this presentation. Find the first 4 derivatives. It means we have to take the derivative 4 times. So we start with y prime. Okay, so y prime, which is derivative of x cubed minus 5x squared plus 2. Derivative of x cubed is 3x squared. Derivative of 5x squared, which is 10x, so minus 10x. Derivative of 2 is 0. So that's y prime. y2 prime is second derivative. Derivative of 3x squared is 6x. Derivative of minus 10x is minus 10. y3 primes is the third derivative. Derivative of 6x is 6. Derivative of negative 10 is 0. And then y4 primes, derivative of 6, which is 0. And that is actually the fourth derivative of this function. There's another notation for second, third derivative, and so on. This would be first derivative. This would be the second derivative. You put it in between parentheses, it means derivative. Otherwise, we may read it as exponent. Third derivative. Fourth derivative. This is a better notation, so we don't have to put so many primes. So this is the end of the presentation. Thank you for watching.